this video, we will talk about and go over some examples on the cardinal number of a union. So before we begin, there are several definitions that we need to make sure we understand, beginning with the cardinal number. So the cardinal number, or sometimes called the cardinality, for some finite set is just simply the number of elements in the set. So it's a nice way to talk about sets or to do any sort of intersection with them or manipulation of sets if we know how many elements are in each set. So that is the cardinal number of the set. And we have this notation for the cardinal number. It is N of A. So that is the number of elements in set A is equal to, and then you write some number. Two other important pieces of definitions that we need to understand before going over these examples today are the union and the intersection. So these are some set theory definitions that we need. So the union of A and B, which we read as A union B, is simply the set that contains everything in A, everything in B, or the things that contain or the elements in both of them. So a lot of times we refer to this as or, A or B, although we have to remember that it does contain the elements in both of the sets. And then kind of on the contrary, we have the intersection, which we read A intersect B, and that is simply just the set that contains only the elements in both A and B. So sometimes we see these represented Venn diagram wise, which kind of helps drill home exactly what we're talking about here. So I'll just kind of quickly draw this for you. So if we were to have A here and B here, the union of A and B is all of those elements. Whereas if we have A here and B here, the intersection is just those guys. So that might help you kind of understand which is which. All right, let's get into some examples. Before we start with these examples, there is this nice union rule or addition rule that's going to come in handy when we are dealing with some of these calculations. And that is when you want to calculate the number of elements in the union of A and B, you can simply take the number of elements that you have in just A, add that to just the elements in B, but then you have to subtract off this piece in the middle. That's this piece right here. So we're going to keep this rule right here so that we can use it as we're working through these problems. All right, let's try the first one. So here we have set A, and we're told what elements it has, and set B, and what elements. And we want to determine the set A union B. So remember, this is not talking about the number of elements. We're just now rewriting the set A union B. Okay, so this is a new set that contains all of the elements in A and in B. And we do not need to rewrite, we don't need to double write numbers. So I see that I have a 3 in both places. I just need to write 3 one time. And I'm going to write them in numerical order. So then I see a 6, I see an 8, a 12, a 13, and a 15. So that is the set that contains all of the elements in A or B or both. So now I can determine the number of elements in the set A union B. So this is the number of elements. Remember that set new notation that we learned. So the number of elements in A union B is equal to, well, it's kind of nice we can just count because we already came up with it. So let's figure out we have 1, 2, 3, 4, 5, 6. Now there's another way that we can do this, and I'm going to show it to you so that it actually applies this nice formula that we just learned. And that formula is the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A and B, or intersect B. So let's plug the numbers into this formula and see what we get. So how many elements do we have in A? Number of elements in A is equal to 3. How many elements do we have in B? 1, 2, 3, 4. So we have 3 plus 4 minus. How many elements do we have in common in both of them, in the intersection? We'll take a look. How many do we have that are the same? We have one single element in common. So we have 3 plus 4 minus 1, which is 7 minus 1, which is 6. So there are kind of the two ways that you can think about calculating the number of elements in the union of two sets. So the first way we did it was we calculated the actual set, and then we counted the numbers, the number of elements, or we just went straight to the union addition rule. We both came out with 6. That's kind of how that works. Let's try another example. Here we have the set S and the set T. Great, this is another one where we can just apply what we just learned in that formula. So we want the number of elements in S union T. Okay, I'm going to write out my formula, which is I want the number of elements in S plus the number of elements in T minus the number of elements in S intersect T. Okay, so I need to find out what all these pieces are. How many elements are in S? Well, I have S right here. I have 1, 2, 3, 4. Plus, how many are in T? 2, 3, 4, 5, 6. Minus, how many do they have in common? How many elements are in their overlap? 3, 6, 12, 15. Okay, so 4. There's 4 elements in their overlap. So 4 plus 6 is 10, minus 4, it's 6. So that's how we use the formula to calculate the number of elements in a union. One last example. If we know that the number of elements in X is 21, and the number of elements in Y is 16, and the number of elements in X intersect Y is 9, what is the number of elements in X union Y? Okay, so this is a little bit different than the problems we've been solving. So we're still going to use that union addition rule that we just learned. But what's different about this is that we weren't actually given the sets like we were up here with the elements. We were given the number of elements in each set. So it's actually a little bit quicker of a problem because we have the numbers to just kind of plug into the formula. So before I begin, it gave me a lot of information. I'm going to just start by writing down the formula that I need to use. So the number of elements in X union Y is equal to the number of elements in X plus the number of elements in Y minus the number of elements in X intersect Y. Now let's plug in what we have. The number of elements in X is 21. The number of elements in Y is 16. And the intersection is 9. Be really careful about what information you're given in the problem, because sometimes you're given maybe this piece and you're asked for another one of these. So just be cautious. But in this case, we are actually looking for what I'm going to call X. I'm going to put that in as a variable. And here we add and we subtract. So X is equal to 21 plus 16 minus 9. So 21 plus 16, let's see, that's 37 minus 9. So X is equal to 28, which X was the number of elements in X union Y.